Imagine an object so old, so impossibly ancient, that when our sun was still just a faint shimmer in a molecular cloud, it was already moving, slowly, silently, between the stars. Before Earth's oceans had formed, before the very dust that would one day become us had even coalesced, this wanderer was already adrift in the interstellar dark. And now, after billions of years of isolation, it has arrived at our doorstep. They call it 3I/ATLAS, the third confirmed interstellar object in recorded human history. But to the team of astronomers in Spain who traced its journey, it is more than a scientific entry. It is a messenger, a cosmic time capsule carrying the frozen chemistry of another sun's creation story. When I look at it, I see more than ice and dust. I see memory, 10 million years of galactic drift condensed into a single fragile traveler. It is a relic from someone else's dawn, a sealed letter from a world that once orbited under alien skies. For centuries, humanity has gazed outward, wondering whether the universe remembers its own past. Now, for the briefest of moments, we can hold that memory in our telescopes. 3I/ATLAS isn't just another comet. It doesn't loop around the sun in an endless ellipse like the icy bodies born in our solar system. It follows a hyperbolic trajectory, a clean mathematical proof that it does not belong here. It came from far beyond, entered our system once, and will never return. A one-way journey through the neighborhood of the sun, a cosmic visitor destined to vanish again into the dark. And yet, in that fleeting passage, it tells a story older than the planets themselves. The first time light from 3I/ATLAS reached Earth, telescopes caught something odd. Its motion was precise, almost clockwork. Its path curved not from random wander, but from a clear gravitational signature, the mark of a body untouched by our star's history. For months, astronomers debated where it came from, what it was made of, and what secrets it carried in its ice. But one group, working quietly on the coast of Spain, decided to look not forward, but backward. At the University of A Coruña, within a facility known as CITIC, the Center for Research in Communication and Information Technologies, a team of astrophysicists, mathematicians, and data scientists set out to rewind the galaxy. Using data from the European Space Agency's Gaia observatory, a spacecraft that has mapped over 1 billion stars, they created a simulation that would let them turn back time by 10 million years. To understand their ambition, imagine this. Every star in our galaxy is in motion. Like dancers in an endless cosmic waltz, they orbit, drift, and tug at one another in a gravitational ballet so slow that no human lifetime could ever notice the change. Over millions of years, their paths twist and weave, reshaping the great spiral of the Milky Way. Now imagine dropping a single grain of frozen dust, a comet, into that ocean of moving suns and asking a simple question. Where did it come from? That's the question the Spanish team dared to answer. They took 3I/ATLAS's current state, its position, velocity, direction, and projected it backward, step by step, through the galaxy. Each tug of gravity from a passing star, each subtle galactic tide, was modeled with exquisite precision. They simulated millions of interactions, what physicists call n-body dynamics, calculating how countless gravitational forces sculpt the paths of celestial travelers. It was like rewinding a film frame by frame until the image dissolved into cosmic fog. Beyond that point, uncertainty overwhelmed the data. But until then, they could trace the journey. 10 million years of history, mathematically resurrected. A galactic archaeology performed not with shovels and fossils, but with photons and equations. Their conclusion was breathtaking. 3I/ATLAS did not originate from any region remotely near our sun's influence. Instead, it likely came from the distant outskirts of another stellar system, a frozen refugee ejected long ago when a massive planet, perhaps the size of Jupiter, flung it free with a gravitational slingshot. It drifted through interstellar space for ages beyond human comprehension, until, by chance or destiny, it crossed paths with ours. For a moment, try to feel the scale of that. 10 million years of travel, a journey across the gulfs between stars. Each revolution of the galaxy changing the constellations overhead while this single fragment of ice wandered patiently toward us. When you trace that path, it's as if the universe itself pressed rewind and for the briefest instant remembered. That's what fascinates me most about this discovery. In a world filled with fear and noise, where so many see the unknown as a threat, this visitor offers something purer: wonder. For once, humanity can look to the heavens and see not an omen, but an opportunity. A safe, silent traveler that brings us no danger, only knowledge. Let me be clear. 3. I/ATLAS poses no risk to Earth. At its closest, it will pass nearly 270 million kilometers away, roughly 1.8 times the distance between Earth and the Sun. A gap so vast that not even the most imaginative headline can twist it into peril. There will be no impact, no catastrophe, no doomsday, only light, cold, ancient light from another world gracing our instruments for a few brief weeks. But that distance does not make it less precious. For scientists, it's perfect. It means we can study the object without fear, like finding a message in a bottle, drifting just close enough to read without breaking the seal. Because that's what 3I/ATLAS is, a message written in frozen molecules. Each atom inside it carries the signature of its birthplace, the radiation of its parent star, the chemistry of its native nebula, the temperature of the dust from which it condensed. By decoding that molecular language, we can read the story of a world that may have existed before ours. Spectroscopy, the science of reading light, is how we listen. When sunlight or starlight hits a material, it scatters and absorbs in ways unique to its composition. A prism or a telescope can break that light into a spectrum, revealing fingerprints of specific elements and compounds. And when scientists aimed that prism at 3I/ATLAS, what they saw was astonishing. This wasn't a typical comet. Most comets in our solar system are rich in water ice. When they approach the sun, that water vaporizes, creating the iconic tails we see streaking across the night sky. But Atlas defied that rule. It was dominated by frozen carbon dioxide, CO2, with only trace amounts of water. That simple fact changed everything. Because CO2 is far more volatile than H2O. It can only remain solid in the deepest cold, far beyond the frost lines where our own comets formed. Its abundance means 3I/ATLAS was born in a region much colder, darker, and older than any environment within our system, a world of perpetual shadow, orbiting perhaps a dim red star or drifting in a nebular cradle long since gone. That chemistry is a fingerprint. It's the accent of another star system. Every ratio of elements, every trapped molecule is like a word in a forgotten dialect. By reading it, we are listening to the language of another world. The ratio of CO2 to H2O, the faint traces of complex organics, the spectral lines of nickel but not iron, all of these are clues. Molecular fossils recording the conditions of a place that no longer exists. To me, that's poetry. Spectroscopy, the way light speaks to matter, is humanity's most elegant form of storytelling. Every photon is a syllable from the past. Every spectral line a verse in a universal poem written long before humans learned to read. So when scientists say they are studying this comet, what they really mean is that they are listening. Listening to the whispers of chemistry older than the sun. There's a beautiful humility in that. We are not trying to command the cosmos, but to understand it. To hold up a mirror and see a reflection of ourselves, made not of flesh and bone, but of the same carbon, oxygen, and nitrogen that drift across the galaxy. 3. I/ATLAS reminds us that the universe recycles itself. The atoms inside you were forged in stars that lived and died billions of years ago. Perhaps some of them once drifted in comets like this one. Perhaps this visitor carries the same building blocks that would one day seed life on another world or ours. If water is the ink of life, Carbon dioxide is its punctuation. Together, they write the grammar of creation. An atlas speaks that language fluently. Some scientists have called interstellar comets the DNA of exoplanetary systems. It's not just metaphor. Each one encodes the environmental history of its birth. By studying enough of them, we can begin to compare planetary systems like biologists compare genomes. Which ones were hot? Which were cold? Which had the right chemistry for organic molecules to form? When we study 3I/ATLAS, we're reading one page of that cosmic genome, a single data point in the library of the Milky Way. But what a page it is, a frozen relic from a star that may no longer exist. And yet amid all this science, there is something profoundly human. Because every discovery like this is, in some way, a mirror. We look out into space to find the origins of other worlds. But what we are really seeking is our own reflection. Each time we decode a spectrum, trace an orbit, or catch a comet's light, we are learning not just about the universe, but about ourselves. When Galileo first turned his crude telescope toward Jupiter, he saw moons, not gods, not omens, worlds. When the Spanish team at CITIC pointed theirs toward 3I/ATLAS, they saw not danger, but data, ancient, elegant, and true. And that is the quiet triumph of science. It transforms fear into curiosity. It turns superstition into understanding. Too often the unknown is met with anxiety. Every time an unfamiliar object sweeps through our solar system, headlines shout alien probe or apocalypse. But the truth is simpler and more beautiful. The cosmos is not mocking us. It is inviting us to look closer. 3I/ATLAS is not a threat. It is an invitation, a challenge to humanity to see mystery not as menace, but as meaning. As it travels through our inner solar system, it will approach perihelion, the point closest to the Sun, around late October 2025. Then it will swing outward again, gliding past Earth's orbit in mid-December, glowing faintly before dawn in the constellations Virgo and Leo. From our perspective, it will look small, a dim greenish point in the sky. But for those who know what they're seeing, that faint glow will feel like the gaze of deep time itself. For a few weeks, humanity will share the same sky with something older than the sun. And when it's gone, we'll be left with the data, the light, and the memory of having been witnesses to a cosmic messenger that crossed the galaxy to reach us. Maybe that's why the story of 3I/ATLAS resonates so deeply. It isn't just about science, it's about continuity, about our species learning to replace fear with wonder, and ignorance with inquiry. Because what greater privilege is there than to stand beneath the stars, aware that we are part of the same story? When I speak of 3I/ATLAS, I'm not just describing a comet, I'm describing a conversation, a dialogue between the universe and the consciousness it created. Each photon reflected from its icy surface traveled millions of kilometers to meet the glass of our telescopes. Each data point we capture is the universe speaking back, saying, "I remember." And we, for once, are learning to listen. The Spanish researchers didn't just calculate numbers, they resurrected history. They built a bridge across millions of years, connecting a forgotten star system to our own. In their hands, mathematics became archaeology, and light became language. That is what makes their work revolutionary. They didn't settle for detection, they sought ancestry. They asked, where were you born? What forces shaped you? What ancient star once warmed your surface? In doing so, they reminded the world that curiosity needs no borders and wonder needs no passport. Europe, often quiet in the headlines of interstellar research, has taken the lead. Gaia's data, the Nordic Optical Telescope's imagery, the computational power of CITIC, all European achievements working in harmony. It's proof that the greatest discoveries come not from power, but from patience, not from fear, but from fascination. And somewhere between those lines of code and the starlight they measure lies a simple truth. To rewind time is not a fantasy. It's an act of imagination guided by science. We have learned to press rewind on the Milky Way itself. And as 3I/ATLAS continues its silent glide past the sun, we are left with a sense of awe and a quiet question. If this is just one messenger among billions, what else might be drifting in the dark, waiting to be found? For now, the answer is beyond our reach. But the search, as always, has already begun. As 3I/ATLAS moves deeper into the inner solar system, something remarkable begins to happen. Our instruments, JWST, Hubble, and the massive ground-based telescopes scattered across Chile, the Canary Islands, and Hawaii start capturing data in a silent chorus. Each telescope sees the same thing, yet each tells a different part of the story, like musicians playing variations of an ancient theme. At first, the public notices only the images, the glowing arc of its coma, the slender line of its tail. But among scientists, there's a quiet excitement. The numbers don't lie. Atlas's composition breaks the pattern. Its spectrum shouts CO2 where we expect water, whispers carbon monoxide in strange ratios, and shows traces of nickel, pure nickel, without iron. That single anomaly sends shockwaves through astrophysics. Nickel and iron are born together in the hearts of supernovae, twins separated only by density and temperature. To find nickel without iron is like finding smoke without fire. Something about the chemistry of this object defies what we know. As one researcher said, it's as if we're staring at a recipe written by a different chef in a different kitchen under a different sun. And perhaps we are. When we speak of comets, we speak of leftovers, debris from planetary formation frozen at the edge of time. But Atlas isn't one of ours. Its molecular ratios tell of a birthplace colder, darker, and less irradiated than anything in our system. Somewhere beyond the reach of our sun's light, it formed in a nebular winter so long ago that its parent star may already be gone. What makes this discovery extraordinary is not only the data itself, but what it implies about life. Because if Atlas carries the chemistry of another world, then it carries the possibilities of another beginning. Think about it. Every time a comet passes near a young planet, it delivers more than dust. It delivers ingredients: water, carbon, nitrogen, organic molecules, the seeds of habitability. On Earth, many scientists believe comets were the couriers that delivered the first molecules of life. If that's true, then ATLAS is more than an alien visitor. It is an emissary of cosmic continuity, carrying the same building blocks that may have started life here and elsewhere. We often talk about the search for life as if it's something distant, hypothetical, confined to exoplanets and telescopes. But what if the evidence has already come to us? What if life's handwriting is written into the chemistry of the visitors that drift between stars? That's what makes 3I/ATLAS so profoundly moving to me. It collapses the distance between the cosmic and the personal. It tells us that the story of life isn't limited to Earth. It's written across the galaxy, molecule by molecule. And yet not all wonder is straightforward. When the first images from the Nordic Optical Telescope arrived in July, they seemed to defy the laws of physics. The comet's tail appeared to point toward the sun, not away from it. Social media erupted. Has the solar wind reversed? Is ATLAS artificial, a spacecraft, a signal? The truth, as always, was both simpler and more astonishing. The so-called anti-tail was an illusion, a masterpiece of geometry performed on the cosmic stage. You see, comets release not just gas, but dust, fine particles that spread along their orbital plane. From Earth's viewpoint, when we happen to look edge-on to that plane, sunlight backlights the dust, making it appear as if a tail stretches toward the sun. It isn't defiance of physics, it's a lesson in perspective. By September, as Earth moved and the angle changed, the illusion vanished. The tail flipped to its expected direction, streaming away from the sun under the pressure of solar radiation. What had seemed impossible resolved into elegance. Even the bright sunward jet that had so puzzled astronomers was no miracle. As Atlas rotated, one active region vented directly along our line of sight. For a few days that vent appeared like a beam, a spotlight directed at the sun. But it was just a trick of orientation, a natural choreography of light and motion. The universe, it turns out, is a patient teacher. It tests our assumptions not to humiliate us, but to refine our sight. When we looked again, we understood. The comet hadn't broken the rules, it had revealed them. That's the beauty of science. Every illusion corrected is another layer of truth uncovered. Each apparent contradiction pushes us closer to understanding the laws that govern everything, from the smallest molecule to the galaxies themselves. But the story of 3 I/ATLAS isn't just about data. It's also about people, the humans who dared to chase a ghost across 10 million years. Far from the headlines and the glamour of NASA or Harvard, a small group of scientists in Spain did something extraordinary. Working in quiet labs at the University of A Coruña, they turned the Milky Way into their laboratory. Using Gaia's vast star map and the equations of celestial mechanics, they recreated the comet's ancient path. What they found wasn't just a trajectory, it was ancestry. By combining Gaia's positional data with high-resolution models of stellar motion, they traced Atlas's likely birthplace to a region beyond the Sun's gravitational reach. Perhaps the outer disk of a long-extinct system, perhaps a cold orbit around a faint red star. Whatever the origin, it was unmistakably interstellar. And so, for the first time in history, we had not only observed a visitor from another star, but reconstructed its journey home. That's why the Spanish achievement matters. It shows that discovery isn't the monopoly of superpowers. The frontiers of knowledge are not owned by nations. They are open to anyone with curiosity and courage. CITIC's simulation, built from mathematics, data, and imagination, rewound 10 million years of cosmic evolution. It was as if the Milky Way itself had turned transparent for a moment, letting us see where the traveler came from. To rewind time is to dream with discipline. And this, more than anything, is the spirit of science. There's a poetic symmetry to it. An ancient object carried by chance into our neighborhood meets a civilization capable of tracing its steps across the galaxy. For a moment, the wanderer and the observer recognize each other. One brings the past, the other brings understanding. That moment, brief, fragile, magnificent, is what it means to be human. Science isn't just a set of tools, it's a form of listening, a way of paying attention to the whispers of creation. And 3I/ATLAS whispers many things. It tells us that the universe is older, colder, and more connected than we can imagine. That every atom of carbon, oxygen, and nitrogen is part of a story written in countless dialects of chemistry. That the dust of other worlds drifts into ours, and perhaps one day the dust of ours will drift into theirs. When the comet reaches perihelion, it will glow faintly against the backdrop of Virgo and Leo, small, almost invisible to the naked eye. But behind that faint light is everything we are: curiosity, patience, and the desire to know. For millennia, humanity has looked at comets with fear. To our ancestors, they were omens, harbingers of doom, warnings from the gods. But now, for the first time, we can see them for what they truly are: fragments of history, ambassadors of cosmic memory. That shift, from superstition to science, from fear to curiosity, is the greatest revolution of all. When Galileo saw the moons of Jupiter, he rewrote humanity's place in the cosmos. When the Spanish team saw the path of 3 I/ATLAS, they reminded us that the story continues, that we are not just passengers on a small planet, we are interpreters of the universe. Somewhere out there, beyond the reach of any telescope, billions of other travelers wander the dark. Each carries a different story. Each holds a different key to understanding the formation of worlds, the birth of stars, perhaps even the emergence of life. But for now, ATLAS is the one we can see, the one we can study, the one we can listen to, and so we do. Our instruments measure its light. Our computers simulate its orbit. Our minds imagine the world it once called home. And for a moment, the boundary between science and poetry dissolves, because this is what true wonder feels like. Not chaos, not fear, but comprehension. The kind that leaves you silent because you finally understand how vast and how beautiful reality is. When future generations look back on this moment, perhaps they won't remember the numbers, or the dates, or the press releases. They'll remember that once, in the year 2025, humanity stood beneath the night sky and listened to a messenger older than the sun. They'll remember that we looked up, not in terror but in gratitude. Maybe that's the real legacy of 3I/ATLAS. Not its orbit or its composition, but its effect on us. It teaches us humility. The universe is not obligated to make sense to us, but somehow it does. It teaches us patience. Answers take time, sometimes millions of years. And it teaches us connection, that every discovery, no matter how distant, is part of the same human story, our need to understand. When I think about that, I realize that 3I/ATLAS is more than a comet. It's a mirror. It reflects the best of what we are, a species that questions, that calculates, that imagines. And that's why we must not meet it with fear. There are always two voices when something unknown appears in our sky. One whispers wonder, the other murmurs fear. Fear is easy, it spreads quickly, fed by uncertainty and myth. But wonder takes effort. It demands courage. It asks us to look again, to measure, to learn. Science at its heart is disciplined wonder, and that is what this moment calls for. Every telescope turned toward ATLAS, every student running simulations, every amateur astronomer taking photos from their backyard, they are all part of this collective act of curiosity. Together, we are decoding the handwriting of the cosmos. We no longer fear eclipses or comets, we measure them. We no longer pray for the universe to spare us. We ask it to teach us, and it does, patiently, brilliantly. When the light from 3I/ATLAS fades in early 2026, when it slips beyond Jupiter's orbit and back into interstellar night, it will take with it the secrets we haven't yet solved, but it will also leave behind a gift, the realization that we are capable of listening. Maybe that's what the universe has been waiting for all along, for one of its creations to become self-aware enough to notice, to record, to care. Each photon we capture is a word in that dialogue, each spectrum a phrase. Together they form the first coherent conversation between humankind and the cosmos. So as Atlas drifts away, we should not feel loss. We should feel gratitude for the privilege of having met it, for the knowledge it gave us, for the reminder that we too are travelers, made of dust, moving through space and time, seeking meaning. There's something beautifully symmetrical about that thought. A fragment of another world travels 10 million years to reach us, only to find that we have built machines capable of understanding it. It took the universe billions of years to create a species that could look back at itself and ask, why? And in that question lies our greatness. When I gaze at 3I/ATLAS through the data, the spectral lines, the orbital plots, the infrared maps, I don't just see an object, I see a relationship between light and life, between silence and understanding, between the infinite and the intimate. For a brief moment, we are part of the same equation. Perhaps that is what it means to be conscious in a cosmic sense, to be the universe becoming aware of its own history. And so, as Atlas fades into the distance, remember this, it is not leaving us. It is reminding us that everything leaves eventually. That impermanence is not tragedy. It's the rhythm of existence. Stars die, comets drift, civilizations rise and fall, but curiosity endures. Because curiosity is the one force in the universe that transcends entropy. It turns chaos into meaning. It keeps the flame of understanding alive, even in the coldest corners of space. So when you look up this December and see the faint light of 3I/ATLAS glimmering near Leo's horizon, know this. You are looking at a messenger older than the sun, a survivor of creation's first dawn, a frozen story that began long before humanity, now passing through our chapter of the cosmic book. What will we write in response? If you had the power to look through the James Webb Space Telescope for just 1 hour, what would you study? What spectrum would you chase? Would you look for water, the signature of life, or for carbon dioxide, the fingerprint of its possibilities? Because every answer we seek is already out there waiting to be heard. The universe has been speaking for billions of years. We are only now learning the language. 3I/ATLAS is one of its first sentences. So let's listen, let's measure, let's learn. Because this isn't the end of a story. It's the beginning of understanding. The next interstellar visitor will come, and another after that. Each one will carry a piece of the galaxy's memory. And each one will remind us that the unknown is not something to fear. It's something to cherish. For in the end, the truest legacy of science is not certainty, but curiosity. And that, more than anything, is what this comet has taught us. 3I/ATLAS may vanish from sight, but its lesson will endure, that in a universe filled with silence, wonder is the one sound we can make that echoes forever.